discussing about stack implementation using linked list concept. Okay, so what is a stack? Introduction to stack. Then how to implement it using linked list. Okay, so this is what we are discussing from the last class, last two sessions. Okay, so we discussed the algorithms. Okay, stack algorithms, create stack, push stack, pop stack algorithm, then stack top algorithm. Okay, empty stack, full stack you can implement easily. Then we discussed the stack count and destroy stack operations. So these are all the algorithms we discussed in our previous session. And also it's equivalent C code. Okay, C implementation also we discussed. Okay, and then the executions. Okay, so execution of the stack output also we discussed. Okay, so some students they discussed with me like the different versions of the linked list implementation that is available in the internet. Okay, whether we can use the such kind of implementation that programs, whether we can use it or not. Okay, so for that I have created one additional video. Okay, it will play around 10 minutes. Okay, in that I explained about what is the difference between the our implementation, that is linked list implementation using uh, two structures, and linked list implementation with only one structure. Okay, so about this I have discussed in this in that video. That video I'll upload it in tomorrow's today or tomorrow in the classroom. Okay, please go through that video. Okay, and today we will start discussing about the applications of the stack. After applications of the stack, we will discuss about the linked list implementation using C++. Okay, as I already told you, you can use either C or C++ code. Okay, suppose if they are asking the coding part in exams, you can use a C code also, C++ code also. As I already told you, I will share the linked list implementation program using CPP. Okay, that we will discuss, and that code also I will share. Okay, so today first we are going to discuss about stack applications. Okay, so if you're taking stack applications, it can be classified into four categories. That is reversing the data, second one is parsing the data, third one is postponing the data usage, and third one is postponing the data usage, and fourth one is backtracking. Okay, example for each of these categories is reversing the data. So reversing data means so whatever the data we are reading in a sequence, we can push it into the stack. After pushing all the data into the stack, if you start popping out the data, it will give the reverse order of the stack. Okay, so reversing the list, reversing the string, these are all examples. Decimal to binary conversion also we can implement using the stack. So in that also we need the logic of a reversing. Okay, so these two are examples for the reversing data application. Parsing data means matching the parentheses in a source program. So when you are writing a C program or C++ Java program, most of the common mistakes that we will do is missing out the closing parentheses. Okay, curly brackets. When you are writing a function which contains nested if statements, while statements, for all these blocks, we will have open curly bracket and also close curly brackets. Okay, so whether all the open brackets and closed brackets are properly closed or not. Okay, whatever the open brackets we used, okay, whether all the open brackets are closed properly or not. Or if you're taking an expression, in expression we will use parentheses. Okay, how many number of parentheses we are having in our expression, whether all the expression of parentheses are closed or not. Okay, so to check this we can use stack. How means whenever we are finding an open bracket, push it into the stack. Okay, and whenever we are having a closed bracket, pop one item from the stack. So after reading all the characters and all the lines, the stack must be empty. Suppose if you have an open bracket, sorry, if you have closed bracket and the stack is already empty, means you missed one open bracket. Okay, suppose stack is not empty and the entire string is over. Whatever the data we need to process, everything is over means you missed one close bracket. Okay, so for matching the parentheses also we can use the stack. So this is an example for parsing the data. The third is postponing data usage. Sometimes whatever the data we are currently processing, that we need to store it somewhere and using it. We may be in need of postponing its usage a little later. Okay, so for the purpose we can use the stack. So read the data, push it into the stack and read the further data, and after that pop from the stack and use it. Okay, postponing the data usage. So this is the another use of application of stack. Here we will there are two examples are there. There is a converting the infix expression into postfix expression and evaluating the postfix expression. Okay. And the last application is the backtracking. So backtracking means suppose you are traveling to a you have in front of you have multiple paths to reach a destination. You are taking one path and in the middle you came to know that that path is wrong. So you have to step back to the previous step and then choose another path. Okay. So for this we need to remember whatever the paths, alternative paths we are having, we had. So then only it's possible to go back to the previous step and choose the alternate path. If that is also wrong, go back to the previous step and choose the alternate path. Okay, so this is choosing the two or more paths, choosing between the two or more paths. This is an example for backtracking. Okay, so these are all the four broad categories of stack applications and example for each of the category. Okay, so in this we are going to discuss about convert infix expression to postfix expression and evaluate a postfix expression. Reversing a list, we in the last class itself we discussed it. We reversed one string. Okay, one string for reversing the string we used stack in our previous class itself. So in today's class we will discuss about how to convert infix expression into postfix expression and evaluating a postfix expression. The C implementation we will discuss in tomorrow's class. Okay, so today we will see only the methodology and algorithm. Okay, so now why we need postfix expression? Okay, so we whatever the expression we are writing, suppose if we are writing a plus b into c, it is an infix expression. Means the operator will come between operands a plus b. It means that plus is coming between a and b. A and b are operands and plus is operator. Okay, so this is infix notation. Prefix notation means we will write the operator before the operand. That is plus a b. This is a prefix notation. Postfix notation means first operand will come, after that operator will come. That is ab plus. Okay. So infix notation, it may be easy for us, means the humans to read and write. Okay, but for machines it is difficult to understand the infix expressions, and the postfix notations are very easy to implement and evaluate. So in the high level languages that like C, C++, Java, even though we are writing infix expression, while parsing, these infix expressions will be converted into postfix expression and then only it will be evaluated. Okay, so the main disadvantage of infix notation is we need to use parentheses to control the evaluation of operators. Suppose we need to control the precedency of operator, means plus must be evaluated before multiplication. Okay, or multiplication must be evaluated before plus. Okay, so like that operator precedency, if you want to override or control, means we need to use the parenthesis. Okay, but in the postfix notation the parenthesis is not required. First we will read two operators, two operands, then we will read operator. Once operator is read, we will use the two operands to complete the evaluation. Okay, so this is what the postfix advantage of postfix expression. Okay, in postfix and prefix notations we do not need parentheses. Each provides only one evaluation rule. Okay, more than one or ambiguous evaluations will not be there in prefix and postfix notations. And a common evaluation technique is to convert the expression into postfix notation before generating the code to evaluate them. Okay, so even though some high level languages support infix, Before evaluating, it will be converted internally into postfix form. Then only it will be converted. Okay, in compilers mostly these concepts are used. Okay, first we will discuss the manual transformation, and then we will discuss about how to convert it into algorithm. Okay. Okay, now manual transformation. So here first there are three rules how to convert infix expression into postfix expression. First, as per the precedency rule, uh, add the parenthesis to each of the individual components. Okay, so there is a first step. Fully parenthesize the expression using any explicit parenthesis and the arithmetic precedency. Okay, there is a multiplication first, it should come, and the division should come first, then addition, then subtraction. So based on the precedency of precedency logic, add the parenthesis. After adding the parenthesis, change all infix notation in each parenthesis to its postfix notation. Suppose within parenthesis, if a plus b is there, okay, that is the individual component. That a plus b must be converted into postfix notation. That is a plus b means ab plus. Okay, after once you complete the conversion of the entire expression, now remove all the parentheses. Okay, now let us take an example. Here infix expression given is a plus b star c. Now step one result. First b and c. Okay, so one parenthesis. After that a plus b into c. Second parenthesis. Okay. Now we need to convert individual expression into postfix expression. So b star c will be converted to bc star. Okay. In the next step, a plus within the bracket whatever available bc star. So it should be converted to a bc star. The plus should come after the close bracket. Okay. See here, a bc star plus. Okay. So in this way, we need to convert the infix expression into postfix expression. This is manual transformation. So after converting this, remove all the parentheses. And this is a manual transformation. Okay, we cannot directly convert these steps into just a moment. Okay, we cannot directly convert these steps into algorithm. Okay, it may be difficult. So what we can do means we can use the stack here. Okay, before seeing how to use the stack in this process, let us take one more example. Okay, another example is given here. This is a little complex. A plus b star c plus d plus e plus f minus g. Okay, so now a plus b, then a plus b into c. Okay, and then e into f, then a plus b plus sorry a plus b into c plus d, that is another component, then e into f, and finally minus subtracting with g. Okay, after adding all the parentheses, convert individual components into postfix notation. Finally remove all the parentheses. Okay, after removing all the parentheses, this is the final postfix expression we are getting. So this is manual transformation. Now actually here what is happening means, see this, let us take the first example. Okay, here we have a in the infix expression. In postfix expression also we have a. We have plus. Plus is not immediately placed in the postfix expression. Next we have b. B is directly placed in the postfix expression. Now operator star. Star is not placed here. C is placed directly. After that multiplication operator, then plus operator. So actually what we are doing here means whenever we have an operand, operand is directly placed in the postfix expression. Whenever we found operator, that operator is placed somewhere for later processing, post the data processing of operators. So plus and star if you are taking, we are not directly moving it to the postfix expression. Okay, we are postponing its usage little later. Okay, postponement. So here we are going to use a stack. Whenever we are finding an operator, push it into the stack. Okay, later pop it from the stack and use it in the postfix expression. So this is where we will use the stack. Okay, now let us come to the algorithm. Okay, this manual operation is difficult to implement in computer, so we can use the stack to perform the conversion easily. So here, if I taking the simple example a star b, it is converted to a b star. So operands first displayed, then operator displayed later. So operators usage, it is postponed. So for this postponing purpose, we can use the stack. Whenever we are finding an operator, push it into the stack, and later, after processing of two operands, pop it from the stack and place it in the postfix expression. So here we can use stack. So postponing the data processing, this is one application of a stack. So that application we can use here. Okay. Now, so infix expression use precedency rule to determine how to group the operands and operators in an expression. Okay, we can use the same rule here also. So in infix expression, multiplication have higher precedency than plus minus means. Here also the same rules we can use. Creating our own rules and make the things complex. Whatever the precedency rules we already know. Okay, the same rules here also we can use expression. Okay, so when we need to push an operator into a stack, so some things, some conditions we need to check. Suppose in the given infix expression, you are reading an operand. Just place the operand in the postfix expression. You are reading an operator. That operator must be pushed into the stack. While pushing into the stack, we need to compare the already available operator in the stack. In stack top, some operator must be there. The current operator must be compared with the stack operator. Okay, which precedency is higher? Suppose if the current operator's precedency is higher than the stack top operator, then push the current operator into the stack. Otherwise, pop the stack top operator and place it in the postfix expression. Then current operator you can push it into the stack. Okay, until you find the lower operator than the current operator, pop all the operators and place it in the postfix expression. This is what the basic idea here. Okay, it may be theoretically look like difficult to understand. Okay, let us take one example. So in the next slide, we can have one example here. Okay, this is a simple example. We'll discuss one more example also. Here, A plus B star C. Okay, now how to convert it? The first rule. If it is an operand, directly place it in the postfix expression. So A is an operand. Place it in the postfix expression also. So in postfix expression also, we placed A. Then we are reading plus. So plus, you have to push it into the stack. Since plus is the first operator that we are reading, that will be the first operator in the stack. Stack is already empty. Now push the plus into the stack. Next, read B. B is an operand. Okay, so directly move to the postfix expression. Next, we are reading multiplication operator star. Now, when you are reading the multiplication operator star, we already have one operator in the stack, that is plus. Now, which is the current operator is a multiplication operator and the stack top is a plus operator. Since multiplication is a higher precedency over plus, directly push the multiplication operator into the stack. So now the stack contains two operators. Top operator is a multiplication operator. Below that we have plus. Okay. Now the next operand is, next we are reading C. C is an operand. So move to the postfix expression. So postfix expression now contains A, B, C. Okay. Now there is no expression, there is no character in the infix expression. All the 5 characters we already processed. So in the postfix expression we have A, B, C, and in the stack we have plus and multiplication operator. Since the input infix expression is over, now we need to read the characters from the stack and place it in the postfix expression. Now from the stack top, read the multiplication operator and place it. Okay, then read one more plus operator and place it. Processing over. Okay, so this is a simple example. We'll take one more example with the stack diagrams also. Okay, here we have a plus b into c minus d divided by e. Okay, now how to convert this? So the infix expression, postfix expression, along with the stack, picture of the stack here illustrated. So first we are reading A. Okay. So stack is empty. Since A is an operand, directly it is placed in the postfix expression. Okay. Next we are reading plus. Since plus is an operator, it is pushed into the stack. Next we are reading B. Place it in the postfix expression. Next, we are reading multiplication operator. Okay, since multiplication operator is higher precedency over the plus operator, directly we are pushing the multiplication operator over the on the top of the stack. So now stack contains plus and the multiplication operator. Postfix expression contains AB. Okay, next we are reading C. Okay, since C is operand, place it in the postfix expression. ABC in postfix expression. Next we are reading minus. Okay, see here, minus is the lower precedency over the multiplication operator and plus operator. So pop the multiplication operator and plus operator into the postfix expression and push the minus in the stack. Okay, so current operator, if it is the higher precedency over the stack top operator, then we can push the current operator. Otherwise, we have to pop the operator from the stack and place it in the postfix expression. This rule we already discussed. So as per that rule, since minus is a lower precedency over the plus and multiplication and plus operators, we are popping the multiplication operator and also we are popping plus operator and placing it in the output expression, that is postfix expression, and pushing the minus in the stack. Okay, so this is over, this step is over. And next we are reading D. D is an operand, so place it in the postfix expression. Next we are reading division. Okay, since division operator is higher precedency than minus, we are pushing division into the stack. Okay, and now we are reading E. E is an operand, so directly place it in the output expression, postfix expression. And now input expression is empty. Okay, we read all the characters from the infix expression. Now stack is not empty. Pop all the operators from the stack and place means concatenate with the postfix expression as per the popping order. Finally, the conversion is over. So the converted postfix expression is ABC star plus DE division minus. So this is the postfix expression. Now, since here we are using stack, it can be easily converted into means the infix expression to postfix expression conversion we can easily implement. Okay, let us check it. Let us check the algorithm for this conversion. And this is the priority we are going to use. Whatever the priority we already know. Okay, so we already know that multiplication division have higher precedency over plus and minus. Okay, and parenthesis is the lowest priority here. Okay, now
sir, if both operators are equal priority, then what to do, sir?
see the first rule. Okay, here when we need to push an operator into the stack, if its priority is higher than the operator at the top of the stack, higher means we need to push, equal or lower means we need to pop and a new operator must be pushed into the stack. Okay, if it is equal means the already in the stack top whatever the operator available that must be popped and the current operator must be pushed into the stack. Suppose in the stack top you have division operator and the current operator is a multiplication operator. Since both are equal, okay, the division must be popped out and the multiplication must be pushed into the stack. Okay, that is equal.
Okay, sir. Understood, sir.
Now let us check the algorithm. So infix to postfix algorithm, the parameter is infix formula. Okay, infix formula is the parameter. It is a valid infix notation, and postfix is it will generate a postfix formula and returns the postfix formula. So this is the algorithm headers. Then creating a stack. First we need to create a stack. Then we need to read each and every character from the formula and process it. Okay, if the character is a open parenthesis, okay, push it into the stack until we find the closed bracket. This must be processed. Okay, so push it into the stack. Else if character is a closed parenthesis, okay, whatever the operators available in the stack, all characters must be read and move to the postfix expression. Okay, so far we discussed about only the plus, minus, division and multiplication operators. The usage of this closed bracket we will discuss in tomorrow's class along with the C implementation. Okay, so this suppose if it is operator, test the operator stack top and the current operator. Okay, until you are finding the lower priority operator, pop all the characters from the stack and concatenate with the postfix expression. Okay, and end the loop. If the character is operand means directly concatenate with the postfix expression. Okay, if input formula is empty, pop all the values from the stack and concatenate it. Okay, finally return the postfix expression. So this is infix to postfix conversion. Okay, and one more thing is we need not write the stack operations for each and every applications. Instead, we can create one stack ADT. In C++, you might have studied one concept called templates. What is the purpose of templates? Any idea?
Sir, we can use the class for any data type, sir.
Yes, correct. Suppose if you are writing a function to find average of numbers, okay, if you are writing the function as a template function, the same function can be used to process integer data and also for float data and also for double data, long data. For each data type, we need not create separate functions. So like that, if you once you created a stack, okay, that stack can be used for characters or numbers or any data type. Okay, so after discussing this application implementations, we will create a stack ADT and use the stack ADT to process all these applications also. Okay, how to create an ADT in C and also how to create ADT in the C++. Both we will discuss. Okay, now the second application we'll discuss. So the second application is evaluating the postfix expression. So evaluating postfix expression means now we discussed about converting the given infix expression into postfix expression. Suppose the values assigned for all the operands in the postfix expression, then how to evaluate the postfix expression and find its final result. Okay, so that is what evaluating the postfix expression. Here evaluating postfix expression means here we have one postfix expression ABC plus star. Assume that A is 2, B is 4 and C is 6, and what is the expression value finally. Okay, so if you are here, it is directly opposite to the previous one. Okay, in the infix to postfix conversion, we are postponing the processing of operators. Whenever we are finding an operator, we are pushing the operator into the stack. Okay, here in evaluating the postfix expression, the first, what is the first value means it is an operand. The second is also operand. Okay, so you have two operands, but you don't know what to do with the operand. Until you find an operator, you cannot perform any operation over these two operands. You have A, you have B. What we need to do with A and B, whether it's a plus or multiplication or division, we don't know. So until we find an operator, okay, we need to keep this A and B somewhere. So A and B must be the processing of A and B is postponed. So in this, we need to postpone the usage of A and B little later. So here we need to store the operand or operator in the stack. What we need to store?
Operand.
Yes, correct. Operand, we need to store it into the stack because operand's usage must be postponed until we find operator. So whenever we are finding an operator, we can pop the operands from the stack and perform the operation and evaluate the result. So this is what evaluating postfix expression. Okay, here the first thing means whenever we are finding an operator, means whenever we are finding an operand, push the operand into the stack. And whenever you are getting an operator, pop two values from the stack and perform the operation and push the result again into the stack. So this is what we are going to do here. Now let us check an example, the same example, 246 plus star. So now we are reading 2. 2 is an operand, push it into the stack. Now 4, push it into the stack. 6, push it into the stack. Now plus we are reading. So plus means since it is an operator, pop two operands from the stack. So 6 and 4 we are popping and performing the addition operation. Result is 10. Push the 10 into the stack. Now next is multiplication. Multiplication also an operator. So now what we need to do means pop two values from the stack, 10 and 2. Okay, apply the multiplication operator. 2 into 10 is 20. Push the result into the stack. Pushed. Okay, now the postfix expression is empty. We processed all the characters. Now stack contains only one value, 20. So 20 is the result. Pop the result from the stack and display it. So this is what evaluating a postfix expression. Okay, as a stack applications, we discussed 4 category of applications. So what are the 4 category of application means? Reversing the data, okay, reversing and postponing the data, parsing, backtracking. So in that postponing data usage, we are discussing 2 applications, that is infix expression to postfix expression conversion and evaluating postfix expression. Now this is the algorithm for postfix expression, evaluating postfix expression. So create a stack, loop, iterate until we reach all the read all the characters from the postfix expression. Okay, if it is an operand, push it into the stack, or if it is an operator, pop two operands from the stack and perform the operation, push the value back into the stack in loop. Okay, so after reading all the characters, the stack will contain only the final result. So pop it from the stack and display it in the screen. So this is what evaluating postfix expressions. So today we discussed 2 applications, okay, about the 2 applications of stack. Okay, as I already told you, now we will see the CPP implementation for list. Okay, so list operation, this is C implementation. Whatever the code I used in this code, list operation through 3 in this file, the same code I have used in this also. Okay, the structure node, I have created a class called a list. In that I have created a structure, the same structure whatever I have used here. Okay, that I have created here. Then the count and then head, location pointer, predecessor pointer. So 3 pointers I have created here. Now public functions. In constructor, I have initialized the count to 0 and head to null. Then insert node. Okay, since the data and the functions which operates on data, okay, everything is within the class. No need to pass the head pointer, predecessor pointer, everything as a parameter to the functions. Okay, so directly I am passing only the data for insert, for searching also only data, deleting also only data I am passing. Okay, display destroy list. See here, this is my class list, which contains structure of the node, one structure node, data means data node as a structure, then count number of values means number of nodes in the list, then head pointer, location pointer, and predecessor pointer. Now, as we discussed in the single structure implementation of linked list, here also we are not going to create the implement the create list. Whatever the first node we are creating, the first node's address will be stored in the head pointer. Okay, first node's address will be stored in the head pointer. Okay, so in insert node, I am getting the data and creating the new node. Okay, and new node's data I am assigning, and the head pointer and new node pointer changes I am applying here, incrementing the count. Okay, and then display. Okay, so display the same way, creating temporary variable walker. If head equal to null means the list is not created, assigning the address in the head to temporary variable walker until walker reaches null, becomes null. I am displaying the data and moving the walker pointer, walker equal to walker next. Okay, so this is CPP implementation. Okay, I am not going to explain each and every function in this class. I'll share this code with you. Please go through this code. If you have any doubt, please ask in the next session, next class. Okay, I'll put on one more additional video regarding the implementation of this class. Okay, now let us see the output of this program. See here the same operations. One, inserted 4 values. Now display. See here 400, 300, 200, and 100. Now searching list. That is 3 is the option. Now I'm searching 300. Search is success. Now again I'm searching. I'm giving 700 as input. It is not available in the list. Okay. Then list count is totally 4 elements. Totally 4 elements. Now delete from the list, display, and then delete for deleting 200 from the list. Delete success. Okay, and the display. Now 200 is deleted from the list. Okay, now again I am deleting some number which is not exist in the list. I'm giving 4000. See, 4000 not found in the list. Okay, so this is how we can implement the linked list using CPP class. Okay, so in today's session we discussed about 2 applications of stack and then CPP implementation, means linked list implementation in C++. Okay, if you have any doubt in today's session, please post your doubts in the chat window.